Welcome to online chemistry video class. Students, today we are going to discuss about the mole concept problems in stoichiometry. It is the assignment 12. Topic is stoichiometry and subtopic is mole concept. So, in which first question is 1 mole of CO2 contains which of the following molecules of CO2 or atoms or other thing. So, here once you check out, here 1 mole of CO2 contains or 1 mole of CO2 is equal to 1 mole of CO2 is equal to its gram molecular weight 44 grams of CO2. It is also taken as 6.023 into 10 power 23 molecules of CO2. So, it is also equal to 12 into 10 power 23 oxygen atoms because of here in CO2 2 oxygen atoms. Under STP condition 6 into 10 power 23 oxygen atoms is taken as 1 mole. 2 into 6 into 10 power 23 oxygen atoms are present in CO2. That is why 2 into 6 12 into 10 power 23 oxygen atoms, that is also equal to 6 into 10 power 23 carbon atoms because of number of carbon atoms in CO2 is 1. Under STP condition 1 mole of carbon atom is equal to 6.023 into 10 power 23 carbon atoms. That is why it is equal to 1 mole of CO2 atoms contains 44 grams of CO2. And also taken as 6.023 into 10 power 23 molecules of CO2. It is also taken as 12 into 10 power 23 oxygen atoms and also taken as 6 into 10 power 23 carbon atoms. So, these 4 is equal to 1 mole of CO2. So, given 4 options, which is correct one? 6.023 into 10 power 23 carbon atoms. That is the fourth option. Got it? Go for next question. What is the question here? The number of atoms in 0.004 grams of magnesium will be, that is the question. 0.004 grams of magnesium contains how many number of atoms? That is the question. So, once you check it, my dear student, here 24 grams of magnesium having 6.023 into 10 power 23 atoms of magnesium because of magnesium atomic number 12 and gram molecular weight is 24. That is why 24 grams of magnesium having 6 into 10 power 23 atoms of magnesium. Then 0.004 grams of magnesium having how many number of atoms? Then 0.004 by 24 into 6 into 10 power 23. You simplify this, you get the answer 10 power 20 atoms. That means here 24 grams of magnesium contains 6 into 10 power 23 atoms of magnesium and 0.004 grams of magnesium contains 10 power 20 magnesium atoms. That is the third option. Got it? Go for next question. What is the next question? The number of atoms in 55.85 grams of iron. He given one hint. Atomic weight of iron is 55.85 gram per mole. Got it? Here the number of atoms in 55.85 grams of iron he asking. So, he given comparative study with other one. Here twice that of 60 grams of carbon, 6.023 into 10 power 22 iron atoms. Of that in 8 grams of helium and 558.5 into 6.023 into 10 power 23 atoms of iron. So, these all are the 4 options given which is related to 55.85 grams of iron. That is the correct answer. So, I am easily explain with this. Right. Here 55.85 grams of iron is equal to here 1 mole of iron because the atomic weight of iron is 55.85. Under STP condition, gram molecular weight of any substance is taken as 1 mole. That is why 55.85 gram per mole means 55.85 grams of iron is taken as 1 mole. Here that is equal to 12 grams of carbon atom. Because of carbon atomic weight 12, under STP condition 12 grams of carbon is taken as 1 mole, that is equal to 1 mole of iron. Next 6.023 into 10 power 23 iron atoms. Under STP condition 6.023 into 10 power 23 iron atoms is taken as 1 mole. Got it? That is also called 4 grams of helium because of helium atomic number 2 and gram molecular weight 4. That's why under STP condition 4 grams of helium is also taken as 1 mole. So, given 4 statements which is related to given 4 options, that is third one. Of that in 8 grams of helium. 8 grams of helium, of means 4 grams of helium, that is taken as 1 mole. Under STP condition 1 mole of any substance is equal to its gram molecular weight. Here 55.85 grams of iron is 1 mole and 4 grams of helium is also 1 mole, that is related to third option. Got it? So, go for next question. What is the next question? The number of molecules present in 4.4 grams of CO2 is 4.4 grams of CO2 contains how many number of CO2 molecules? That is the question. Got it? So, I explained with a suitable answer. Here under STP condition, here mole concept is calculated at STP condition. STP means standard temperature and pressure. Here standard temperature is 273.15 kelvins and pressure is 1 atmosphere. At this condition, here 6.023 into 10 power 23 molecules of any gas is taken as 1 mole, that is not only CO2. You take N2, O2, H2, CO2, Cl2, I2, whatever it you take. Under STP condition 6.023 into 10 power 23 molecules of any substance is taken as 1 mole. Now, here he asked the 4.4 grams of CO2 contains how many number of atoms, that is the question. Got it? So, under STP condition 44 grams of CO2 having 6.023 into 10 power 23 molecules of CO2, that is 1 mole. Now, 44 grams of CO2 having 6.023 into 10 power 23 molecules, then 4.4 grams of CO2 contains how many number of molecules? Like here 4.4 by 44 into 10 power 23 into 6.023. Got it? You simplify this, here you get the answer 6.023 into 10 power 22 molecules of CO2. That is the answer. Where it is it? Fourth option. Got it? Simply 44 grams of CO2 contains 6.023 into 10 power 23 molecules. Then 4.4 grams of CO2 contains 6.023 into 10 power 22 molecules. Got it? Next question. Here, what is the next question here? Here, the number of atoms present in 4.25 grams of ammonia approximately. The number of atoms present in 4.25 grams of ammonia approximately. 4.25 grams of ammonia contains how many number of atoms he asked? He is not asking number of molecules. He is asking how many number of atoms present in 4.25 grams of ammonia. That is the question. So, you apply the mole concept here. Ammonia gram molecular weight 17 because of nitrogen gram molecular weight 14 and each hydrogen gram molecular weight 1 and 3 more hydrogen gram molecular weight 3. 14 plus 3 is 17. That means, under STP condition 17 grams of ammonia having 6.023 into 10 power 23 ammonia molecules. And each ammonia contains how many number of atoms? 4 atoms. 1 nitrogen atom, 3 hydrogen atoms. 4 atoms are present in each ammonia molecule. And also 17 grams of ammonia having 6.023 into 10 power 23 ammonia molecules into number of atoms 4. That means, here 17 grams of ammonia having 6 4s are 24 into 10 power 23 ammonia atoms. Then 4.25 grams of ammonia contains how many number of atoms? Then you simplify 4.25 division with 17 into 6.023 into 10 power 23 into. Yes. Next question. Here 4.9 grams of impure potassium chloride on heating shows the weight loss of 0.384 grams of 4 grams. What percentage of impure potassium chloride has been decomposed? That is the question. First of all, you find out decomposition reaction of potassium dichloride. Here potassium chloride formula KClO3. When KClO3 thermally decomposition to produce KCl solid and liberate the O2 gas. Here 2 moles of KClO3 decomposes to produce the 3 moles of O2. It is the losing of weight by mass here. 2 moles of KClO3 weight is 245 grams. That means 245 grams of KClO3 thermally decomposition to lose the 96 grams of O2. Got it? Then he asked the 4.9 grams of potassium chloride decomposes by losing weight is what 0.384 grams. So first of all you find out here 4.9 grams of potassium chloride decomposes. Is it losing 0.384 grams or other substances? Got it? Here 245 grams of potassium chloride thermally decomposes losing 96 grams of oxygen. Because of 245 grams of KClO3 is equal to 2 moles and 96 grams of O2 is equal to 3 moles. Now 245 grams of potassium chloride thermally decomposition loss 96 grams of oxygen, then 4.9 grams of potassium chloride decomposes, then how many grams of O2 losses? So then 4.9 by 245 into 96, then you get the answer is 1.9 grams. Got it? Actually 4.9 grams of potassium chloride decomposes, it lost the 1.9 grams of O2, but here given 0.384 grams only. Now what is the percentage of potassium chloride decomposes? That is the question. Suppose if 4.9 grams of potassium chloride decomposes, it lost the 1.9 grams. Then 1.9 grams is taken as 100%, then 0.384 grams is taken as how much percentage? That is the decomposition of potassium chloride in percentage. Then 0.38 by 1.9 into 100, you simplify, you get the answer is 20%. That means only 20% out of 4.9 grams of potassium chloride, only 20% of KClO3 only decomposes. Suppose here 4.9 grams complete decomposes, you get the answer is 1.9 grams. But experimentally you get the answer is 0.384 grams only. That means complete 4.9 grams of potassium chloride do not undergo decomposition. So in which a few grams of potassium chloride only decomposes, that's why he given the 0.384 grams. So that is the 20% of potassium chloride only decomposes out of 4.9 grams. That is the answer. Got it? So where is it? 20% is first option. I hope you understand. Got it? Go for next question. What is the next question? Here for a given reaction N2 gas plus 3H2 gas gives less 2H3, identify dihydrogen as limiting reagent in the following reaction. So here which of the following reaction hydrogen is act as the limiting reagent? Limiting reagent means here X number of moles of hydrogen participated in chemical reaction compared to addition number of hydrogen molecules. So I explained with suitable examples. Got it? So here first option you take 56 grams of N2 combined with 10 grams of H2. In this hydrogen is act as limiting reagent or not. Got it? Suppose here 10 grams of hydrogen is consumed or more than 10 grams are required. In this case it is not a limiting reagent. Suppose here 10 grams of hydrogen participated, less than 10 grams are consuming, then in this case it is taken as limiting reagent. Got it? So first option you take here 28 grams, N2 gram molecular weight 28 grams of nitrogen combined with 6 grams of H2 to produce the 34 grams of ammonia according to chemical reaction. Got it? Now 28 grams of N2 react with 6 grams of H2. 28 grams of N2 react with 6 grams of H2, then 56 grams of N2 react with how many grams of H2? Then 56 by 28 into 6, that is the 12 grams. Actually required number of grams of hydrogen is 12, but here 10 grams only consuming. That means hydrogen here limiting reagent. Got it? So, here limiting reagent means here less number of molecules of hydrogen consuming compared to experimental value, that is taken as limiting reagent. Here according to mathematical calculation 12 grams of hydrogen is requiring, but here participated 10 grams only, less than requiring number of moles, that is indicate here hydrogen is taken as limiting reagent. Go for remaining options also. Now you take B option, 14 grams of N2 combined with 4 grams of H2. In this case hydrogen is limiting reagent or not, once you check it. Generally according to the equation 28 grams of N2 react with 6 grams of H2. Then here second option, what is this? Here 35 grams of N2 combined with 8 grams of H2. In this case hydrogen is limiting reagent or not, check out. So according to reaction 28 grams of N2 combined with 6 grams of H2. Got it? Then 35 grams of N2 combined with how many grams of H2? Is it 8 or less than 8 or more than 8? Once you check out. So then 35 by 28 into 6. Then you find out the answer 7.5 grams. Actually requiring 7.5 grams, but here participated 8 grams, more than requiring value. Then in this case hydrogen is not taken as a limiting reagent. Got it? Next, third option, here 14 grams of N2 combined with 4 grams of hydrogen. Is it compared to relation is what? Here according to statement 28 grams combined with 6 grams of H2. 28 grams combined with 6 grams of H2. Then 14 grams of N2 combined with how many grams of H2? Then 14 by 28 into 6. Here requiring number of grams of hydrogen is 3, but here taken 4. So more weight of hydrogen taken compared to requiring value. Here also it is not taken as a limiting reagent. Next fourth option is what? 28 grams N2 combined with 6 grams according to equation, exact number of grams of H2 taken is, in this case also it is not taken as limiting reagent. Limiting reagent means here participated number of grams of hydrogen is less compared to experimental value. In this then only that is taken as limiting reagent. Here suitable answer is first option only. So if first option only, hydrogen is considered as a limiting reagent. Got it? Go for next question. Here it is the standard level question and also previous mains level question. So first of all try to understand the question here. Got it? So what is the question? A 10 milligrams of effervescent tablet containing sodium carbonate and oxalic acid here releases 25 ml of CO2 at 298.15 kelvins and 1 bar pressure. If molar volume of CO2 is 25 liters, under such condition what is the percentage of sodium carbonate in each tablet? Got it? Here 10 milligrams of effervescent tablet is containing sodium carbonate and oxalic acid. So that particular tablet contains sodium bicarbonate and oxalic acid, both are there. So here this tablet from sodium bicarbonate, carbon dioxide gas is released. How much carbon dioxide gas released? 0.25 ml of carbon dioxide is released at 298.15 Kelvin temperature and 1 bar pressure. So 0.25 ml of CO2 releasing at 298.15 kelvins and 1 bar pressure. In this case, how much percentage of sodium bicarbonate present in? How much percentage of sodium bicarbonate present in each tablet? Because of here CO2 gas released from sodium bicarbonate only, because of here sodium bicarbonate plus oxalic acid, this both substances are present in this tablet. When undergoes reaction takes place to give the product is sodium oxalate water plus CO2. That means here 2 moles of sodium bicarbonate consuming 2 moles of CO2 formation takes place. Got it? So in this case, first of all you find out how many grams of sodium bicarbonate present in the how many grams of sodium bicarbonate present in the 25 liters of solution. First of all, you find out. So, here temperature given, pressure given, volume given, then you apply the ideal gas equation. Ideal gas equation is what? PV is equal to nRT, ideal gas equation. Then number of moles N is equal to PV by RT. Then P indicate pressure in 1 bar is equal to approximately 1 atmosphere pressure, because of 1 atmosphere is equal to 1.01325 bars. That is approximately taken as 1 atmosphere is equal to 1 bar. That is why pressure taken in atmosphere, and volume is taken in liters 25 by R value, ideal gas constant R value in liter atmosphere 0.0821 into temperature in kelvins, here 298. Got it? You simplify this, you get the answer 1.02 into 10 power minus 5 moles. Number of moles of Na2 sodium bicarbonate in the tablet is 1.02 into 10 power minus 5. Now, you need to find the weight of sodium bicarbonate present in the tablet. Then weight of sodium bicarbonate is equal to number of moles into gram molecular weight. Number of moles of sodium bicarbonate is what? 1.02 into 10 power minus 5 into its gram molecular weight is 84. So, its value present in grams, but we need to represent it in milligrams. 1 gram is equal to 10 power 3 milligrams into 10 power 3. Then you simplify, you get the answer here, that is the 0.8568 milligrams. That means for a given tablet 0.8568 milligrams of sodium bicarbonate is present. Got it? So, when you take 1 mole of sodium bicarbonate, 1 mole of sodium bicarbonate consuming 0.8568 milligrams of CO2 is appears. Got it? Then 10 milligrams of sodium bicarbonate contains how much percentage of sodium bicarbonate? That means here 10 milligrams is taken as 100%, then 0.8568 milligrams is equal to how much percentage? Then 0.8568 by 10 into 100, then you get the 8.568%. That means here 10 milligrams of tablet contains 8.568 percentage of sodium bicarbonate. In this way, we can easily find out the answer. So, 8.568, where is it? First option. That is the answer for this question. Got it? So, go for next question. What is the next question? If we consider that 1 by 6th in place of 1 by 12th mass of carbon atoms is taken to be the relative atomic mass in it, the mass of the 1 mole of substance will be, here you take 1 by 6th place and 1 by 12th mass, whatever it, that place is changes 1 by 12 to 1 by 20, 1 by 100, the mass is changes 1 by 12, 1 by 20, 1 by 100, whatever it, 1 mole of substance is always constant, it never changes, because of mole concept is measured at STP condition. That's why here its value always constant, they never be changes. Got it? The mass of 1 mole of substance is always constant, they never be changed, because of it is measured at STP condition. That's why answer is remains unchanged. Right, next question. The volume of hydrogen gas at 273 Kelvin temperature and 1 atmosphere pressure will be consumed to obtain the 21.6 grams of elemental boron from the reduction of boron trichloride by hydrogen. That means here boron trichloride undergoes treated with hydrogen to give the elemental boron and hydrochloric acid. Here, according to reaction, 2 moles of BCl3 treated with 3 moles of H2 to give the 2 moles of elemental boron. That means 3 moles of H2 consumed to give the 2 moles of elemental boron. He asked the volume of hydrogen gas consumed to obtain the 21.6 grams of elemental boron. 3 moles means here under STP condition 1 mole is taken as 22.4 liters. 3 moles is what? 3 into 22.4 liters to give the 2 moles of elemental boron. 2 moles means what? 1 mole is equal to gram molecular weight, that is the 10.8. 2 moles is equal to what? 10.8 into 2, that is equal to 21.6 grams. That means 3 into 22.4 liters, that is equal to 67.2 liters of hydrogen consumed to give the 21.6 grams of elemental boron. That is the answer. Where is it? 67.2 liters of hydrogen. That is second option. Got it? So go for next question. What is the next question? Number of atoms in 560 grams of iron. Here atomic mass of 556 gram per mole. That is the iron atomic mass. Got it? Here he asked the question is number of atoms in 560 grams of iron. So he given statements are what? Twice that of 70 grams of nitrogen, half of that of 20 grams of hydrogen, both A and B and none of these. So he asked the 560 grams of iron is equal to twice that of 70 grams of nitrogen and half of that of 20 grams of hydrogen or not. Got it? So here under STP condition 56 grams of iron is taken as 1 mole, then 560 grams of iron is equal to what? 10 moles. Got it? In the same way under STP condition for 14 grams of elemental nitrogen is equal to 1 mole. Then twice that of 70 grams means 140 grams of nitrogen is equal to 10 mole. Yes, compares to each other. Here 560 grams of iron is 10 moles. Here 140 grams of nitrogen is also 10 moles. Then you take with respect to hydrogen. Here half of that of 20 grams of hydrogen. Half of that of 20 grams of hydrogen is 10 grams. Half 10 gram, 20 grams half is 10 grams. Here under STP condition 1 gram of hydrogen is taken as 1 mole. Then 10 grams of hydrogen is called what? 10 moles. That means here according to given statement 560 grams of iron is equal to 70 grams of nitrogen and 10 grams of hydrogen. All are taken as 10 moles. 560 grams of iron is 10 moles. 140 grams of nitrogen is 10 moles and 10 grams of hydrogen is also taken as 10 moles. That means here both 1 and 2 are correct. Got it? Because of here I am applying the mole concept. So under STP condition here gram molecular weight of any substance is taken as 1 mole. Here 56 grams is taken as 1 mole. Then 560 grams of iron is taken as 10 mole. In the same way, here 14 grams of elemental nitrogen is 1 mole. Then 140 grams is taken as 10 moles. Then in the same way, 1 gram of hydrogen is taken as 1 mole. Half of that 20 grams means 10 grams. 10 grams of hydrogen is also 10 moles. So 10 moles, 10 moles, 10 moles, all are same. That means both 1 and 2 are correct. That is the third option. Got it? Okay students, thank you.